everyone, myself Sravanthi, working as an assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today my topic is elimination of left factoring. So here I'm going to discuss what is left factoring, why we need to eliminate the left factoring by applying some examples, and we are going to learn few rules how to eliminate this left factoring here. So what is left factoring? So a grammar is said to be left factoring when multiple production rules for non-terminals have a common prefix, then that grammars we are going to tell it as a left factoring. So nothing but here in the right hand side of the production rule, so the first letter is common in all the production rules, nothing but we'll be telling it as a common prefix. Here alpha is there here in the first production, here also alpha is there, here also alpha. So if we are finding the common prefix in the in the right hand side of the production, then we are going to call it as a left factoring. So grammar is said to be left factoring when multiple productions for a non-terminal having a common prefix. Here the common prefix is alpha for the A production. So then we are going to tell it is a left factoring. So here alpha represents the common prefix and beta, beta 1, beta 2, beta 3 are nothing but the remaining parts of the productions which can be different from each other. We can apply anything over here. So the common prefix over here is alpha. So whenever we find in the production rules the common prefix, then we will be telling that it is in left factoring. So we need to eliminate that left factoring. So why, if we have a left factoring, what is the problem? So if the left factoring is there here, I cannot derive the string. So nothing but to derive a particular string like id plus id. So which production rule I need to take? In the starting symbol for all the production rules are pointing to the same alpha. So which production rule I need to take in order to generate the string this one? So there will be a confusion. So in order to overcome these ambiguity, we are going to eliminate this left factoring. So top-down parsers like recursive descent parsers need determine which production rule to be used based on the given input. So that is nothing but parser cannot immediately determine which production to rule. So nothing but multiple production rules are sharing the same common prefix. So which production rule I need to apply in order to generate the given string. So that is the problem, the recursive descent parsers. Nothing but this problem will be faced in the top-down parser. So in order to, so that is the reason we are going to eliminate this left recursion over here. So the elimination of left recursion. So to eliminate the left recursion, we need to identify whether the given production is in the left factoring or not. So first we need to identify whether there is any common prefix in the given production rule. So and identify, we are going to introduce a new non-terminal. So nothing but if it is E, we will be implementing a new non-terminal as E dash. If it is A, we are going to introduce a new non-terminal that is nothing but A dash. And we are going to rewrite the production rules. Once we rewrite the production rules from the original production rules, we are going to eliminate the left factoring here. So here consider the following left factor grammar. See here, A produces alpha beta 1, alpha beta 2, alpha beta 3. If the production is in the form of these one, nothing but here alpha is pointing to the common prefix and beta 1, beta 2 are nothing but the some production rules. We are having some productions. And here the common prefix we have identified is alpha is the common prefix, and the new non-terminal which I am going to produce is A dash. So simply we will be producing the new non-terminal or new production rule from the start symbol. If I am having here A, I will be producing A dash. If it is E, we will be producing E dash. If it is S, we will be producing it as S dash. So we are going to rewrite the given production rule by applying some new production rules, and we will be getting the new grammar. So A produces alpha A dash, and A dash is producing beta 1, beta 2 and beta 3. So here the production, if it is in the form of these one, A produces alpha beta 1 or alpha beta 2 or alpha beta 3 or alpha beta 4. So if the production is in the form of this, we are going to generate or we are going to produce a new grammar, or we are going to rewrite the production as A produces alpha A dash. Alpha is nothing but the common prefix and A dash is nothing but the new production rule. So now A dash can be replaced with this beta 1, beta 2, beta 3, beta 4. Beta 3, beta 4. So now this grammar is free from left factoring, and these can be applied for the top-down parsing. So let us see few examples over here. S produces if E then S, comma else S. If E then S. S produces A. So if I'm having these production, so what we are going to have? So where we need to check whether the given production or whether the given grammar is having left factoring or not. So how we will be identifying whether the grammar is having left factoring or not? So here we need to check the common prefix over here. So this is yes, all these three productions are pointing to the same one. These productions are pointing to the same one. So here if E then S, if E then S. So the common prefix I am having is if E then S. So nothing but alpha is pointing to if E then S. If E then S. So what we are going to get here? A produces alpha A dash. A produces, so A produces alpha A dash. A dash is nothing but beta 1, beta 2 and beta 3, so on. So this is the grammar, this is the new production rule we will be having. So here it is nothing but this alpha is nothing but if E then S. So what we are going to get here? So for this grammar, S produces, what is alpha I am having? Alpha is if E then S. If E then S. So A dash. A dash is nothing but A is nothing but S. So I am going to get here S dash. S dash. The next I am having is A dash. So A dash is producing nothing but S dash is producing what it is producing? Else S. Else S. So nothing but else yes. Else yes, and we'll be getting here epsilon. So here the non-terminal I am having is A. A I am having. So this is nothing but the production rule for the new production rule for the existing grammar. So let us see one more example here. A produces AB, AC, AD. So here the common prefix I am having is A. A is the common prefix I am having. So I can, and the next string, next production is B is producing B, C is producing C, D is producing D. So in the remaining three production rules, I am not having any common prefix, but in the first production, I am having a common prefix that is nothing but A. So how we are going to eliminate? So nothing but what we will be having? A produces alpha A dash. A dash is nothing but beta 1, beta 2 and beta 3. So it is in the production of A produces alpha, beta 1, alpha, beta 2, alpha, beta 3. So what is alpha? So how I can write A? Here A is there, A dash, and A dash is nothing but what I am having? Beta 1 is nothing but B, beta 2 is nothing but C, beta 3 is nothing but D. So the remaining three productions are as it is. So I have applied these two production rules for these left factoring and I got these are the two things. So the new grammar is, this is my new grammar. So this new grammar I can apply it for the top down parser. So one more example. Given grammar is A produces A, B, C, D, A, B, E, G, A, B, E, F and A, G. So what is the common letter I am having here? So here the common letter I am having is here A, B, and here I am having A. So let me take the common prefix as AB. Let me take the common prefix as AB. So here a common prefix is nothing but AB is the common prefix I am taking. A, beta 1, A, beta 2, sorry, alpha, beta 1, alpha, beta 2 I am having here. So this is nothing but AG. Here I am having. So what we are going to get here? So alpha A is produced as A is nothing but alpha is nothing but AB, A dash, AB, A dash and AG. And A dash is producing CD and EF. CD and EF. So this is the grammar. We will be getting the new grammar over here. This is the new grammar we are getting here. So further, we need to check first for the given grammar, we need to check whether any left factoring is there or not. If a left factoring is there, we need to eliminate by applying the production rules. So first we need to check whether the given grammar is having the left factoring or not by checking the common prefix. Whether the given production rule is having the common prefix. Yes, if it is having the common prefix, we need to apply the new production rules and we need to derive the new terminal and then we will be getting the finally the new production rule for the existing grammar. So the new grammar can be applied for the top-down parser and we can apply it for the recursive descent parsers and it is free from the left factoring and it will be generating the strings also.